Thanks so much. I'm really happy to be speaking with you today about some of the nuts and bolts of the embedded ethics curriculum. So a deeply integrated approach to including ethics in the computer science curriculum. And just a little background, I'm really honored to be speaking with you here today. Normally, I'm a cross-appointed professor at Northeastern University between ethics, philosophy, and computer science. And before that, I worked with Mehran Zahami at Stanford as the first embedded ethics postdoc there. So that's the work I'm going to be speaking about with you today. And the mission of embedded ethics, as you've heard, is inspired by Dr. Yoon and the vision that she had for embedded ethics, which we were really honored to be able to try to put into practice. And I'm just really grateful for the support and for all of the leadership that you had to create this program. So the mission is training the next generation of computer scientists to consider ethical issues from the outset, rather than building the technology and letting the problems surface downstream later. And the way we want to do this is by integrating these skills and habits of ethical analysis throughout the computer science curriculum. So how do we do that? So I'm going to focus on the practical aspects of how to create an embedded ethics curriculum. Which courses do you focus on? How often? What is the content? And who are the people that are doing it? So this will build on what Dr. Zahami presented earlier. Okay, so which courses? I want to argue that embedded ethics should begin in introductory computer science classes. And I think this is maybe an argument that is not obvious or that other people might disagree about, because in a way, the upper level courses seem to be a more natural target for ethics. You might start off and say, hey, we should put ethics first in reinforcement learning. We should put ethics first in the courses where students are building technologies that are much more similar to the technologies that we're worried about in day-to-day life. And that is intuitive. But I think actually, if resources are limited and if you have to start somewhere, I think it makes more sense to start with the introductory courses. And there are 3 reasons for that. The first reason is that if part of what we are hoping to do is make embedded ethics naturalizing, so make it a natural part of the computer science curriculum, then students have to learn to be a responsible computer scientist at the same time that they learn to be a computer scientist at all. So it has to be that learning these ethical techniques and habits is a standard part of the curriculum, and because of that, it can't just pop up 3 years into their education. It has to be there from the beginning. And likewise, if these are habits that we're hoping to train, the best habits start young. And so these habits should start from the first time that people are taking computer science courses, so that every time they're building a program throughout their education, they are thinking in this way that includes ethical analysis. And finally, as instructors, the most important thing, of course, is why it's good for the students. But as instructors, it's very helpful to be able to know what the students already learned. If you're only doing the upper level courses, the upper level courses are often elective. And so people get to choose which course they take. And so you have no idea, in a class, what ethics material students have already encountered. Whereas if you start with the intro classes, then you know what concepts they've already encountered, what skills they've already practiced, and you can build the curriculum on that basis. So we focus on the required courses in the undergraduate curriculum. So as Mehran said, we focus on the courses that students have to take. And then secondarily, we have these gateway courses where if you want to go on to do higher level study in artificial intelligence, you have to take, for example, Intro to Artificial Intelligence. If you want to go on to higher level study in human-computer interaction, you have to take Intro to Human-Computer Interaction. So this is another good site for ethics because, again, there are mandatory bottlenecks to the later courses that students take. And so I looked up the required undergraduate curriculum at KAIST, and I saw it's almost exactly the same. So to me, these would be wonderful places for ethics, and I would love to talk further with anyone who's interested in putting it in these courses. Okay, great. So that was the first point. Which courses focused on these required undergraduate courses to build ethical habits from the beginning? Second, how often? This is another perhaps counterintuitive thing. In order to build responsible habits, ethics should be embedded in everything that computer science students do. As Maron was saying, we learn by doing. We don't learn by even charming and charismatic people like Maron talking about things. We learn by what assignments we do, what labs we do, what exams we do, what exams we study for. And so ethics has to be in all the things that students do. And this means it has to be graded. I think this is sometimes another barrier for people is, can we actually grade ethics? Well, if we don't, it's not a naturalized part of the curriculum. So we have to figure out a way to make a rubric that can be graded so that students can be graded on it like other parts, other skills that they're learning, and other parts of their education. Okay, so with these 4 primary learning goals, issue spotting, values and design choices, moral language, and professional responsibility. How do we incorporate those? So I wanted to give you a few examples. So this is a class, Computer Organization and Systems, that is very common in almost all CS programs. And here they have this weekly assignment structure format, and we embedded ethics in 5 of the major assignments. And I wanted to walk through a little bit what this would look like in this class. I picked this class because it's one of the classes that people say, how can you put ethics in that? You're teaching them assembly language, you're teaching them C++, you're teaching them all this really boring stuff about compilers. Where is the ethics? So we went through and we included those 4 different learning goals in the syllabus. So issue spotting. Let's practice looking at what seems to be just a technical decision and spotting what are the potential ethical issues that might arise in this seemingly technical decision. Professional responsibility. So one of the things that computer science students learn in this course is documentation. And documentation is something that is the basis of secure code, testable code, reliable code. So we can talk about documentation as an example of their professional responsibilities and put it in the context of other responsibilities that we're hoping that they will commit to. Moral language. So this is an important part of the embedded ethics curriculum because when students go out in the world, when they are talking to other engineers, they need language to talk about the subtle issues that they're trying to explain to others. Let's say they have completely embodied the embedded ethics curriculum, they want to make responsible choices, they will have to persuade other people who maybe don't agree with them or have the sort of sophisticated language to be able to explain, okay, all of us think that we're doing the right thing, you think that you're doing the right thing, I don't think you're a bad person at all, but let me subtly explain to you why the thing that you're proposing to do has a moral concern. And in order to do that, they need to develop language for the precise kind of issue that they're identifying. So in the 3rd assignment that we included, we introduced some moral language that might not be familiar to all of the students, partiality. And we say, there are some concepts of ethics where we think that they apply to everyone equally, to all degrees. So if you think that ethics is about reducing suffering, you might say you have an equal duty to everyone to reduce their suffering. But there are other ethical concepts that are more partial, where you have special duties to some people because of your relationships to them. So for example, you have special duties to your parents. You have special duties to your children. Those can also be ethical duties, even though they're not universally applied. And so we use this concept of partiality to talk about responsible disclosure of security vulnerabilities. So there are some people who think that it's okay for nation states like the United States to hoard security vulnerabilities and use them to hack into other people and other countries' systems. And there are other people who think that that's not okay, that it's not okay to say you have a special obligation to your citizens. Instead, you should have an obligation to all of humanity to an equal extent. So we can talk about this concept of partiality as soon as students start being able to exploit vulnerabilities themselves and being able to start answering the question of, should they be an ethical hacker? Should they do penetration testing? Should they embark in these types of activities? And finally, we end with a case study that covers other types of professional responsibilities they might have. So this is just to walk you through all the different ways that these 4 pillars can appear in one class. But as we go through the curriculum, we try to do an equally thorough approach with all of these classes. So I won't walk you through in as much detail, but here's the Intro to AI class. And you can see, again, we have ethics in all the major assignments. And each of those ethics interventions are trying to bring about different of those 4 pillars of the learning goals. Okay, so starting in the beginning and including ethics in as many assignments and things that the students do as possible. So we want to be ambitious with embedded ethics. So what do we actually include? So as Maron was mentioning, there are different strategies for including ethics in computer science. One strategy is to have a standalone ethics course. And I'll just give you a spoiler right now that I'm going to say we should do all 3 of these strategies. I'm not going to say that one is better than the other, but I am going to say that they have different capacities. So a standalone ethics course is wonderful because it introduces students to the more perhaps complex ethical topics. It gives them time and space to debate. It introduces topics that are not settled, where students can disagree with each other and practice the moral language at more length. But a standalone ethics course, if that's all we have, it sends the message, ethics is something that we do one time, and then we just forget about it. And likewise, the embedded ethics module, where you have one full class day, is wonderful because it is in the computer science class. It is suggesting that ethics is a part of computer science. It's part of your standard job as a computer scientist. And setting aside a full day for ethics gives you that time and space to learn a specific concept and practice it on an associated assignment. So what does this look like? So we have some kind of full class lecture, and then we have some kind of associated activity that allows students to practice what they've learned. So here's an example from Computer Science 1, the class that Maron mentioned. So a lot of times when we're entering a class, we might start with some kind of assignment that already exists in that class. So in this case, there was an assignment called baby names. So baby names said, you have this data set. The data set is of the most common names over the past 100 years in the US. And let's create a little graph, a little GUI, to show how the popularity of a name changes over time. So you can put in that name and it'll say, oh, Jane is becoming less popular, but Mary is becoming more popular. So a lot of times in embedded ethics, we want to focus on assignments that already have some kind of problem that we can improve. So it's a win-win. So the obvious problem with this assignment is that this assignment was only really fun for students whose name were in the most popular 100 name, which is actually not most students. So Maron, Kathleen, none of these names are in the most popular 100 names. And it was especially exclusionary to students who didn't have traditional Western names. So we said, okay, let's keep the basic idea. Let's graph something. But let's change it and have it be something that gives us an opportunity to talk about ethics. So let's graph data from ratemyprofessors.com, where students are talking about professors. And let's see, is a professor's gender correlated with the language that students use to describe them? So let's have the same idea of graphing different words, but now we're going to graph these different words about professors. So we keep all the same computer science learning goals. We keep nested data structures, GUI, data processing. But now we add new ethics learning goals. We can understand the bias in these data sets. We can learn different definitions of fairness and say which ones are being instantiated by this data set. And then we can also say, you have enough tools to formulate new problems with your creativity and moral imagination, so let's practice that. Okay, a third strategy is called micro insertions. So for the modules, we need a full day, and that's great. We have to do that. We should do that. But what about the other days of the class? Well, I don't think we should give up on those either. So micro insertions is the strategy of saying, let's make it an everyday part of the curriculum by adding social context to assignment problems and adding mini lectures as needed to explain what's on those assignments. So if you have some kind of abstract computer science problem, a lot of us in this room are computer scientists, and we know that computer scientists love to make these problems that are like, there are 17 bleep bloops, and there are 37 bloop bloop, and they're on an island and they have to solve this problem. Okay, so that's fun, that's silly, but we can probably add a little more social context to this problem. So can we add a framing narrative to an existing problem and transform it into some kind of realistic dilemma that a computer scientist might face? So let's start with that intervention on the assignment, and then whatever lecture we need to include to explain that, we can do that as well. So here's an example of this kind of intervention. So there was an assignment that used to be called Binary Bomb, and it had a silly story about Dr. Evil, and Dr. Evil has these binary bombs, which are executable files, and the students have to learn how to identify the exploits in the executable files and defuse the bombs. So it's actually a really good computer science lab, but the story, we could take or leave it. So now we keep the CS assignment intact. It's still the same activity that they're doing, but we change the framing story. So now the students are helping a bank to investigate a breach of customer data in their secure vault. And every time they defuse the bomb, they get more customer data. And so this lets us help with a couple things. First, they're taking on this social role in this class of the penetration tester, of the person who is trying to help the bank to figure out what security vulnerabilities they might have. And so we get to help them practice, learn the ethical responsibilities of that social role. But also, as they defuse the bomb and get more data, we can talk about privacy, because these different data sets about the customers can be combined to learn things about the customers that you couldn't have learned from any one data set alone. So we can talk about concepts like differential privacy and introduce those skills. So if we combine these two approaches, if we combine modules and micro-insertions, we actually get a lot of ethics into one CS class. So let's look at how this works with CS1, the first class. So there's an image processing assignment, and we keep that mostly the same. But because we're processing images, we can now talk about manipulated images online. We can talk about truth online. We can add 2 questions to the existing homework assignment. And we can add a micro lecture. We can add 10 minutes to explain the questions so they can answer them well. There's a question about strings and text processing. So we can talk about ASCII, Unicode, representing languages, the importance of linguistic and cultural diversity. And so we can add 3 questions on that assignment and another 10 minutes of lecture. Likewise, if we have questions about encryption and cyber, we can talk about privacy and use this as our sort of bedrock first introduction of privacy in this first class. add 2 questions about privacy, and another 10 minutes. Then we have our module. Thank goodness. We get 90 minutes to actually really delve in. But this is not the first time they've seen ethics. Now ethics is just a regular part of the class, and this is something that is helping them to contextualize it with a lot more information about bias and fairness. And that also lets us ask more questions on that assignment about ethics. And finally, we end with Bajillion, a search engine, and we can talk about ethics of search. So without losing a lot of computer science class time, we've added a lot of opportunities for the students to think about ethics in this class. And this strategy of micro insertion, I think, is very friendly to computer scientists and very friendly to the idea that we can add responsible computing across the curriculum without necessarily taking away from the existing technical material. So, is what I just said true? I think so, and so does this recent study, Brown 2024. So she looked at micro insertion, and she was able to show that students will learn the same amount of technical material whether or not ethics are included. So she had this pretest, what did the students know before? Then she divided them into 2 groups, technical-only instruction and the microethics insertion. And then she has a post-test. And then what I like even more is she has 2 weeks later, what do they still remember? And she's able to show that the 2 groups are very similar in the amount of, there's no statistically significant difference between the amount of technical content they learned. So I think as we're considering this as computer science professors, as we're saying, can we do this? Or as we're considering this as social science and humanities professors, can we convince our colleagues to do this? One powerful tool in that convincing toolkit, I think, is to say, we can do this, we can add this without losing any of the important technical content. So how do you actually do this in practice? So I think there are a lot of ways, and what I found is, at first, when you sit down with any professor, and I'm sure I would be like this as well, and you say, let's look at the syllabus and think about where we can add ethics. At first they say, it's impossible. My syllabus is jam-packed, it's carefully engineered, everything in it is vital, we can't cut a single minute. I feel this way. But then you sit with them and you say, absolutely, I hear you, it's all important. Walk me through what's happening. And then they say, oh, well, in week 7, we do have that full class, visit from someone in industry. And then in week 4, I let them go early to prepare for the exam. And then in week 11, and you're like, okay, there's actually a lot of room here for ethics. So I think just having that patience with all of our very natural attachment to the syllabus and being willing to really look in fine-grained detail and say, what are the spots? Where are the spots for ethics? And that's true in terms of class time. So what I just talked about, where are the spots in the actual lecture time? But that's also true for assignments. So all of us have assignments that don't work. All of us have assignments that worked okay, but the students have never liked them as much as they like other assignments. And those assignments are great places to start, because once those assignments succeed, and you can say, hey, this is actually better than the way it was before, that's a toehold to say, oh, well, if the students like this new assignment, let's try one of the other ones. So I think just having that patience with searching for opportunities in the syllabus can go a long way. Okay, so how often? As often as possible. What content? These modules and micro insertions that together build ethical habits and center human values in the computer science curriculum. So who is doing this? Well, a lot of people in this room, and that's why it's been so wonderful to share strategies and learn from other people in this room. And I think what tends to work best are these interdisciplinary teams, where there's some kind of ethicist who can create some kind of consistent framework for ethics and embed it across the whole curriculum. And then there's the computer science professor who's normally teaching the course. They know how they want the technical material to be taught. They often already have ideas for where to add ethics. There are things that they care about. There are things that they are passionate about, where they've always said, hey, I've wanted to add something about privacy, but I'm afraid to talk about it, or I don't want to say the wrong thing, or I don't know, I just think privacy is important, but I don't know, what are the technical terms for different kinds of privacy? And so that kind of collaboration can be really productive, because working together, the ethicists can empower the computer science professor to include the material that they want to include, but haven't known how to talk about in a formal or technical way. And then I think equally important is some sort of computer science grad student or course assistant or teaching assistant who's worked with that class before and already has familiarity with the technical assignment materials. So this is the person who will sit down and help the computer science professor write new starter code or change the autograder. So all of these kind of nuts and bolts things that go into changing assignments that if you leave the computer science professor totally alone, they might reasonably say, hey, I'm way too busy to do this. I need help. I don't have time for ethics. But if you say, we can make some of the changes you've always wanted to make to the assignment, we can make it work better, they're going to be on board. So I think this sort of synergistic relationship between someone who's bringing both the technical or social scientific knowledge of ethics and the confidence to talk about these topics in an academic way, plus the computer science professor themselves, plus someone who can ease the way and make it a little bit easier to make this transition can be really powerful. So one of the things that I was really surprised to learn is that embedded ethics is important because without it, engineering students' belief in the importance of public welfare actually declines throughout their engineering degree. So I might have thought, we're trying to make engineering students more ethical than the baseline. But one way to think about it is, at the very least, we're trying to stop the bleed. We're trying to make it not the case that over the course of their education, engineering students become less committed to ethics. So ideally, we're going to, of course, I hope, help engineering students be above the baseline in their commitment to social responsibility. But at the very least, one reason to do embedded ethics is to stop the decline that we see over the course of engineering education. And you see this in both, so time 1 and time 2. Time 1 is before they start their degree, time 2 is after, and time 3 is after they've already started working. So you see this consistent decline in engineering students' evaluation of professional and ethical responsibilities as important, in their evaluation of the importance of understanding the consequences, and in their evaluation of the importance of understanding how people use machines. And so because we're combating something that is happening, long before embedded ethics came on the picture, you might ask, does embedded ethics change this? And I think, although the results are still early, we do have some results to suggest that it does quite a bit. So this is results after one module, so not this kind of approach across the whole curriculum. This is just before and after one module. The students say that they're better at noticing ethical implications. The students say that they have greater appreciation of ethical concerns, that they're more motivated to address ethical concerns in their career. And you can see that there's a change in all of these things after just one module. So I think that's very encouraging. I hope we do more testing, but I think the early results are very good that this kind of approach to embedded ethics works. So I've suggested we should start at the beginning, make ethics pervasive, employ both modules and micro insertions, and do it with interdisciplinary teams, and that we should think it works. So thanks very much, and thanks as always to Dr. Yoon and Dr. Sahami for supporting this work.